So for my SATC 112 class on workplace hazards, those chemical, physical, and biological, I decided to do my presentation on radiation. And first thing we need to know is, what is radiation? Radiation is one of several types of physical hazards that workers may encounter while on a job or while working. Radiation exposure can come from different aspects of a job. This exposure can come from the TV sets, microwave ovens, cell phones, computer monitors, natural gas, drinking water, cigarette smoke, radon gas, and even soil and rocks from contaminated areas. Health effects of radiation. Radiation can have some very aggressive and long-lasting effects on the human body. Small exposure to radiation has a smaller increase in the chance of having cancer later in life. Larger exposures to radiation can cause loss of hair, cardiovascular disease, skin burns, and acute radiation syndrome. Acute radiation syndrome from a large amount of radiation exposure can cause nausea, vomiting, and in some cases, death within the next few days. How does radiation enter our body? Natural radiation can enter your body in two different ways, through water intake or through oxygen intake. Natural radiation in Earth's crust is washed away into underground water, thus into our drinking water. Also, natural radiation on Earth's soil surface can get blown around, thus turn airborne, and contaminates the oxygen we breathe. Other forms of radiation can enter your body by passing through it, and as it does, deposit energy as it goes. Now, since radiation is so dangerous to humans, there have been limitations and standards set on it as to the amount of exposure allowed while working. So the American Conference of Governmental Industrial Hygienists, or the ACGIH, has set a threshold limit value, or a TLV, for radiation. And for UV, it's 180 to 400 nanometers, which is nm. The exposure of unprotected eye and skin should not exceed, which is this little formula, T max equals 0.003 JCM squared, and the EEFF. Yeah. So it is all broken down. That's how they figure it out. The Tmax is the maximum exposure time in seconds, and the EEFF is the effective irradiance. So the NIOSH, or the National Institute for Occupational Safety and Health, set a recommended exposure limit, or a REL, at a wavelength of 254 nanometers, which is 0.2 watts divided by centimeters squared for 8 hours of radiation. And as always, the Occupational Safety Health Administration, or OSHA, has its own threshold limit value for radiation. And OSHA's threshold limit value for radiation is 10 MW divided by square centimeters. And that's all. So